All right, so now we're going to deal with taking the derivative of natural logs. Now this chapter 3.9 deals with taking derivatives of exponentials as well, but I'm going to save that for the next unit. So of any of the suggested problems, just look for the ones that say LM. There's just a few of them, but I've got some problems from a different book as well that are photos of problems that you can do as well. Okay, so the derivative of the natural log is 1 over x. Now, note x has to be greater than 0. Reason it has to be greater than 0 because our natural log domain is strictly positive. You can't take the natural log of 0 or a negative number. It doesn't work. All right. So the derivative of the natural log is just 1 over x. The natural log of x, 1 over x. And they've got basically the chain rule down here. So if you're taking the natural log of some function g of x, it's 1 over g of x, and then multiplied by the derivative g prime of x. So problem 340. Using our basic formula, 1 over the function, so this guy here will be our g of x. F prime of x is equal to 1 over that whole thing, so 4x cubed plus x. And then I need to take the derivative of the inside. And the derivative of the inside is 4x cubed becomes 12x squared when we take the derivative of it. And the derivative of x is just 1, so plus 1. And, you put that on top and you're done. I'll make a cleanup step, but and there's really nothing to factor. You're done. And if you want to leave it like I had in the first line, that's fine too. Okay, this next guy involves the product rule. So the first is x squared. The derivative of ln of 9x is going to be 1 over 9x times the derivative of 9x, which is just 9. And then plus ln of 9x multiplied by the derivative of x squared, which is 2x. And I'll clean this up a little bit, but it's really, what, 9? Well, I can cancel out the 9s. So let's actually do that. Cancel out the 9s. I can cancel out one of the x's. So get rid of that. So this is just x. Okay. The next part, however, is 2x ln of 9x. Okay. And again, you don't need the parentheses around the 9x as you see in the problem. It's just assumed that unless you have a parentheses after it, it's not bad. So I separated the 2x here using the parentheses, but I left the 9x next to the ln, assuming that it was all part of it.